Welcome to Deeksha Online Mathematics. Lecture 8. Today we will discuss limits, continuity, derivatives and applications of derivatives. So major points I will discuss because the basic points you're already maybe very strong in that. So main points which are very important, those points I'm going to discuss. Derivative of inverse function. So here suppose y equals to f of x. Suppose x, this is f of x. So y equal to f of x. So there is a function g for which y is x. For y, x is the image, means g of y equal to x. Let this g is inverse of f. Then can I say this is g of g dash y. Let us differentiate with respect to y. Then dx by dy. So what is dy by dx? F dash x. So I can say 1 by f dash x. So the meaning here is this g of y equal to x, if you take, in place of y you can replace f of x is x, identity function. So g dash of f of x into f dash x is 1. So from this you can find derivative of inverse function. The limit of a function at a point. See, the main idea of limit is, with some example I will tell. Limit x tends to 2x square minus 4 by x minus 2 if I am asking. So what we are asking, suppose if you draw the graph of this function. So what is the graph of that function actually? You know that x square minus 4 by x minus 2 is nothing but the line y equals to x plus 2 but x not equal to 2. So how the line y equals to x plus 2 will be there? So what is the x intercept? Minus 2 and y intercept is 2. This is the line. But please remember at 2 that will have a hole. So whenever you are given these questions and if you substitute 2 in that, you are getting 0 by 0 indeterminate form, means at that point the function has no image, means it is indeterminate form at that point. The limit question is not at that point. Limit always asks you when x is approaching to 2, means there are two possibilities. When x is from 2 minus delta to 2 or 2 to 2 plus delta. This is called left neighborhood, right neighborhood. So when approach is from left neighborhood or from right neighborhood, where the y value means I can say y coordinate, which is nothing but the functional value, is approaching. So that is the question meaning. So it is not at x equal to 2, what is the value of y? It is, the question is when x is approaching to 2, where the y coordinate is approaching. See, that is not attaining, it is approaching. So I can get that value if I fill that hole. So filling that hole and creating the new function, actually new equivalent function I have to create by filling this hole. For that we have several processes, rationalization, L'Hospital rule, whatever formulas you are applying, please try to understand. Every time if you substitute, you will get an indeterminate form. Some work you will do to attain. See this problem, I am telling one example. So if I factorize and cancel, I'll get x plus 2. Is it not changing this function into a new function? The difference in between these two functions is, this is with the hole, this is filled hole. When I fill the hole, when x, if I substitute, I can see this hole is on the line, not on the xy plane. So if I fill that hole, I can see approach is to what. So if approach is to which y coordinate, if I want to see, I have to fill the hole. So the entire chapter, limits chapter, lies in this logic only. You have to learn the different procedures to fill that hole And to create a new function, actually it's not a new function, it's an equivalent function. The extra thing is filled hole. Why to fill hole? Then if I substitute it extends to 2 or extends to a in that function, I should get what is its y coordinate. So I can say this is the approach. So this is what exactly limit sense. So please remember, in all the concepts in limit, every indeterminate form, if you observe, if you get this indeterminate form, approach this, all approaches are only leading towards a creation of new equivalent function after filling the hole, so that you can get its approach. Some problems you need infinite expansions. I think you know that Taylor series f of x plus h will be f dash 0 plus f dash h. First will be f of h, constant. Let me write constant first. F of x plus h is f of h plus f dash h by 1 factorial into x plus f double dash h by 2 factorial into x square plus so on. Then if I substitute h equal to 0, I'll get any function expansion. So f of 0, f dash 0 by 1 factorial into x, f double dash 0 by 2 factorial into x square plus so on. So if you use this for the functions where derivative at 0 exists, you can write infinite expansions for any function. Let us take e power x example. So f of x, e power x is e power 0, which is 1. Derivative of e power x, h0, 1. So x by 1 factorial. So like that you can create any functions infinite expansions using this formula. So Newton-Leibnitz formula, this is a very famous formula, you know. Whenever you have a definite integral and bounds are the functions, then how to integrate it means how to differentiate it. So there is a function I of x, integral g of x to h of x f of t. Then if I want I dash x, simply substitute the upper bound into upper bound derivative minus substitute the lower bound into lower bound derivative. So in solving some limits problems, you know L'Hospital rule we have to use when you get 0 by 0 or infinity by infinity models. Suppose if you have a question extends to a f of x by g of x, you will get either 0 by 0 or infinity by infinity. You know L'Hospital rule says that limit extends to a, you can do f dash x by g dash x. Still if you get any one of these forms, again you have to differentiate separately numerator and denominator. So in some questions where you have integrations in the numerators or denominators, by using derivatives you can use these things. Okay, so this is also very important one. So limit n tends to infinity 1 by n sigma r equal to g of x to h of x, f of r by n equal to means actually this left side is limit as a sum. This we will convert into a definite integral. The way you have to convert, see please observe the form 1 by n sigma f of r by n. So this r1 we will take as x, and just for the sake of understanding we are saying that this 1 by n will become dx, and how to create the upper and lower bounds is a and b. A is nothing but g of x by n as limit n tends to infinity. B is nothing but limit n tends to infinity h of x by n. Please remember r by n will be x. So wherever you see r by n, you will replace it with x. 1 by n becomes dx, and you have to convert this into a definite integration, and you can solve that limit question using definite integration. Continuity at a point. So suppose f of x is a function at x equal to a, you will have f of a as the image. But when limit extends to f of x approaches to what is the question. So here you know that left hand limit, right hand limit means when x is approaching to a, where the function is approaching is one question, and at a, what is the functional value? That is second question. If these two are equal, actually you know that in limit, you know, left hand limit will be there. Limit x tends to a minus f of x, limit x tends to a plus f of x. If it is equal to f of a, we say it is left continuous. It is equal to f of a, we say that it is right continuous. So approaching value and functional value should be equal. Then only it is continuous. Otherwise it is discontinuous. Generally discontinuity will be different forms. Okay, before that, continuity in the interval. See, continuity at a point I discussed. See, for example, if I want to discuss continuity in the interval a comma b, it should be continuous at each and every point in open interval, and at a right continuous, at b left continuous. Then only it will be continuous in the total closed interval a comma b. See, continuity you can understand very simple. A simple example I'll tell you. Suppose if you take signum function, signum x definition is 1 when x is greater than 0, 0 when x is 0, minus 1 when x is less than 0. Suppose if I ask you, let us discuss continuity at x equal to 0. Observe, this is a graph of signum. So as limit x tends to 0 minus signum will be minus 1, limit x tends to 0 plus signum is plus 1, but functional value is 0. Observe carefully. As you approach towards u means x value, as x is approaching to 0 from left neighborhood of 0, the function is telling that I am approaching to minus 1. As x is approaching to 0 plus, means from the right neighborhood it is approaching, then the function is saying that I am approaching to plus 1. But the functional value at 0 is 0. That's why it is neither left continuous nor right continuous. And you cannot remove this continuity because signum is already defined. So we cannot remove. So there are some discontinuities which, suppose if you take the question, a function f of x equals to x square minus 4 by x minus 2. Tell me, at x equal to 2, is it continuous? No, it is not continuous, because f of 2 itself does not exist. So at 2, if function is not defined, we will say it is discontinuous. But when x is not equal to 2, this is a function equal to 4 when x equal to 2. If I give one more definition for the function, at x equal to 2 it is 4, then it will become continuous. So there was a discontinuity which I removed it. Now there are some discontinuities which are non-removable. So in that, finite, this is also called jump. For example, if you see the previous example, signum, it is a finite discontinuity. Then what do you mean by infinite discontinuity? See, for example, if I say for finite, one example, I am telling one more example. Tan inverse 1 by x at x equal to 0, it will be discontinuous, which is non-removable. It is called finite removable. What do you mean by infinite? Infinite non-removable discontinuity means that functions always tend to infinity. Means, for example, limit x tends to 1, x by 1 minus x. So either they will say tend to plus infinity or minus infinity. They will tend to plus infinity or minus infinity. Then such functions are called infinite non-removable functions. Then oscillatory. Oscillatory means if limit extends to f of x does not exist, but it oscillates between two finite quantities. Please listen the statement. For example, limit extends to 0, sine of 1 by x, sine of 1 by x. You observe you can't tell this is a particular value, but I'm sure that this limit sine of 1 by x means what? 1 by x as extends to 0 minus 1 by x will be minus infinity, as extends to 0 plus 1 by x will be plus infinity. Whereas sine minus infinity of sine minus plus infinity, I don't know what is its exact value, but I am sure that it is a finite value between minus 1 and 1. So those are called oscillatory non-removable discontinuity. Next, differentiability at a point. Suppose you have a curve at a point A, comma f of A, means generally we say at x equal to A, means we speak x coordinate. Suppose if I take left side, say for the understanding sake I am taking a with far distance, but it is the point in the immediate neighborhood, means it's the point immediately left. It is the point immediately left. So let it is a minus h, then f of a minus h. Then what will be the slope of this secant line? So limit, first slope, let us write the slope. The slope is f of a minus f of a minus h by a minus of a minus h. Your wish, slope can be written in any order. Then when I apply limit h tends to 0, the secant line will become a tangent line like this. So it will become slope of the tangent line, but it is a slope coming from, it is a slope of approach from left side tangent to the tangent. So this is called f dash a minus if it is y equal to f of x. Please try to understand. My question is, at a, what is the derivative is my question. Then how I am calculating it? In the left neighborhood I am taking a minus h comma f of a minus h. Then if I join them, I will get a secant line. Get its slope. Apply limit h tends to 0. So what is this? This is the slope of secant line. This is the slope of secant line. When limit h tends to 0, that slope of secant line tends to slope of tangent line. That is nothing but left hand derivative of that function at x equal to a. Left hand derivative. Now if I take right side a plus h comma f of a plus h, again that secant line slope f of a plus h minus f of a by a plus h minus a as limit h tends to 0. So this is called right hand derivative. But please try to understand here in this figure which I am showing you, left side secant line tending to a tangent line, to the same tangent line right side secant line is also tending. Means if you come from left neighborhood or right neighborhood, both secant lines are coinciding with the same tangent line, then only, means indirectly f dash a minus f dash a plus should be equal, then only derivative exists at x equals to a. So left hand derivative, right hand derivative must be equal. So when differentiability won't be there? When differentiability won't be there? Okay, first let me discuss differentiability in an interval. It is just like continuity, all same. In the open interval, if you want to say that it is differentiable, it should be differentiable at every point. If it is closed at a right hand derivative, it be left hand derivative should exist. Now my question is, suppose if a function is discontinuous at some point, see blindly you can say that at that point it is not differentiable. It is not differentiable. So if differentiation should be there, means it should be continuous, but doesn't imply that continuous function is always differentiable. For example, take mod x function. So function is f mod x. Now I want to discuss at x equal to 0 what is the differentiability. So if I take a left neighborhood point, the secant line of that and tangent line of that are both coincide. If I take a right neighborhood, the secant line of that and tangent line are always coincident. Means left side tangent is slope is -1, right side tangent slope is +1. Means at 0 derivative does not exist. Suppose same question for mod x at x equal to 5 I am asking. So at x equal to 5 means somewhere here 5 comma 5 the point. From left neighborhood, right neighborhood, both our tangents are same. They are coinciding with which line? This line itself. What is the slope of this line? 1. That will be the tangent. See, what is the derivative that f of x definition is what? F of x equal to x if x is positive, equal to 0 if x is 0, equal to minus x if x is less than 0. Then what is f dash x you are getting? F dash x is 1. F dash x is 1 when x is positive. 0 if x is 0. Minus 1 if x is less than 0. At x equal to 5 means x is positive. Derivative is 1. See, that only we are telling. At x equal to 5, left side or right side, that is same straight line, it is coinciding. That's why derivative at 5 is 1. Suppose if I ask derivative at some -7, it will be -1. But derivative at 0, left side is -1, right side is 1. That's why derivative does not exist. So if you observe carefully, suppose if the curve is like this, at 0, assume the curve is like this, then left side secant line, right side secant line are not coinciding with the curve. That secant line will tend to this line, right side secant line also tend to x-axis, both will tend to x-axis. What is the difference here? If you observe this at x equal to 0, this curve is continuous and it is called smooth, whereas in mod x it is called sharp. Whenever there is a sharpness, that left side secant line will coincide with that graph itself. Whenever smoothness is there, left side secant line won't coincide with the curve. That is the difference. Please remember, non-differentiability means only two cases. Either it should be discontinuous at that point or continuous but with sharpness, means sharp continuity. There are a lot of things in derivatives. If it is 1 power infinity, what to do, 0 by 0, say all these things are basic issues. Errors and approximations also basic only. But I want to tell you something, what we exactly calculate in errors and approximations. So whenever we have a function let us say something like this, no need of x and y axis. Just let us take a function. This is x comma f of x. This is x plus dou x comma f of x plus dou x. Suppose if I ask you, when there is a small change or error in x, that is dou x, there is this error in y. What is that error in y? Suppose if I say y equal to f of x is a function, dou y is the change in y, which is f of x plus dou x minus f of x. This is the exact error in y. But how to approximate it? That is the error. But directly if we ask calculate that error, it is a very lengthy process. So I am simplifying that process. What I am doing? What is the slope of this? Slope of this is nothing but what? Difference in y coordinates by difference in x coordinates is what? F of x plus dou x minus f of x by x plus dou x minus x. So that is exactly what error, dou x gets cancelled, dou y you are getting. Now listen carefully. Suppose if this dou x is very small, very small. So I want to apply limit dou x tends to 0. Then you know that right side becomes f dash x. Then this dou y is approximately equals to f dash x into dou x. So what I can say, the exact dou y is f of x plus dou x minus f of x is approximately equal to f dash x into dou x. From this, what you can say, f of x plus dou x, if you want, it is f of x plus f dash x into dou x. Where this will be useful? Suppose if I ask what will be the tan 46 degrees value. So 45 I will take as x and dou x I will take as 1 degree. Then if I use this formula, I will get tan 46 very easily. Suppose if I want cube root of 124 or 125, 125 is very easy. 124 or 126, I'll take the function f of x as cube root x. Then x will be 125, whose perfect cube you know. Then dou x you will take according to the question minus 1 or plus 1. So this last final step which I got, f of x plus dou x minus f of x is approximately equal to f dash x into dou x. With that you can do approximations very easily. There is tangents and normals and rate measure. So in tangents and normals, important thing is, suppose if you have a curve, you have a curve like this, let us say. At a point P, you are drawing a tangent, let us say. So PT is the tangent. T is the point where it is meeting x-axis. So if you differentiate the curve at P, you will get the slope of the tangent. If you draw a perpendicular here, assume that Pn is the normal at P. The negative reciprocal of the slope of tangent is slope of normal. So if you know the point, you can differentiate them at the point, differentiate the curve at the point, get the slopes and get the equations. Now from P, if you draw a perpendicular to x-axis, let it be S. Then remember this ST is called subtangent, this SN is called subnormal, and this PT is called tangent and PN is called normal. So here four words are there: tangent, normal, subtangent, subnormal. Subtangent, subnormal are coinciding with x-axis, so their equations are y equal to 0. And you know how to get the equations of tangents and normal. And important thing is lengths of tangent, normal, subtangent, subnormal. There will be formulas. You know, I think x1, y1 is the point, m is the slope. Then subnormal will be, length of subnormal will be mod y1 m. Subtangent will be mod of y1 by m. Subtangent will be y1 root 1 plus m square by m. Subnormal will, normal will be y1 root 1 plus m square. Please learn all the formula. They will be very important. In doing, see, the advanced, they don't ask direct questions, but they will be useful in calculations of other problems. So I think you know Lagrange's mean value theorem. If a function f of x is continuous in closed interval, differentiable in open interval. Suppose there is a function. Suppose this is a comma f of a. This is b comma f of b. B comma f of b. Then if you join them, you will get a secant line. Assume that you are dragging it. That secant line you are dragging. Means a parallel tangent line you are generating. Suppose if its x coordinate is c, so please remember there exists a c in between a comma b such that f dash c, what do you mean by f dash c? Slope of the tan will be equal to f of b minus f of a by b minus a, slope of that secant line. So this is nothing but, see how we are telling geometrically, what I said is there exists a tangent line which is parallel to the secant line. Means there exists a c such that f dash c means I am telling that there exists a tangent. So the original meaning is, if f of x is a function which is continuous in closed interval a comma b and differentiable in open interval a comma b, then there exists a c in open interval a comma b or closed interval a comma b such that f dash c is equal to f of b minus f of a by b minus a. This is called Lagrange's mean value theorem. Now Rolle's theorem is some extension. Suppose if this f of a and f of b are equal, when f of a or f of b are equal, then the secant line will be parallel to x-axis. Then what I can say, there exists a c such that f dash c will be 0. F of a and f of b are equal. Please remember that secant line is parallel to x-axis. Then there exists a tangent which is parallel to x-axis. That's why its slope will be 0. That is Rolle's theorem. Critical points. So critical points is a set of points where f of x does not exist or f dash x does not exist, means derivative does not exist, or f dash x equal to 0. So any one of these three conditions, if they satisfy, it is a collection or set of points, either f dash x should not exist or f dash x should not exist or f dash x should become 0. Those are called critical points. Remember that critical points should be in the domain of the functions. Then what do you mean by local maxima? So to test at a point the function has local maxima or not, we have different procedures or tests. Suppose my question is, at x equal to a, I want to test whether it has local maxima or not. Then there is a test called first derivative test. What do you mean by local maxima? The function at that point x equal to a, it should be like this. So what is happening with the function? When I say that at this point f dash a equal to 0, at that point f dash a equal to 0, means if you draw tangent, it will be parallel to x-axis. That has a geometrical sense. But please remember, f dash a will be 0. And f dash a minus f dash a minus f dash a plus. So what is happening if you observe carefully? In the left neighborhood, function is what? Increasing. So it will be a positive number. In the right neighborhood, function is decreasing. So it will be a negative number. Means, can I say like this? F dash x is changing from positive to negative through 0. That's why at that point, see, a function is increasing, then it decreased. So the change is happening at a point. That point is called local maxima. That point is called local maxima. That is called first derivative test. Then what is second derivative test? Second derivative test will be f dash a will be 0 and f double dash a in second derivative at that point will be negative number. F double dash a will be negative number. There is another test called higher order derivative test. What will happen? F dash a, if it is 0, suppose f double dash a is also 0, then if you go on like this, triple dash, 4 dashes means fourth derivative, fifth derivative, like that. Suppose at a stage where n is even, means you are going like this, nth derivative, let us say this is n times at a, you are getting less than 0. See, nth derivative at a, you are getting less than 0. If n is even, when n is even, you have to remember this is very, very important. So first derivative 0, second derivative 0, third derivative 0, fourth derivative you got less than 0. Then we will say that it is local maximum at that point. But if n is odd, then x equals to a is not an extremum point. It is called a point of inflection. It is called point of inflection. See here, don't confuse yourself. When we say point of inflection, I am repeating my statement, listen properly. Suppose there is a function, I calculated f dash x. I got 0. Please remember f dash x, odd derivative. I got 0. Then I calculated f double dash. If it is less than 0, then local maximum. Close it. Now suppose I got f double dash also 0. F double dash at that point x equal to 0. Then I will go for f triple dash, which is again odd derivative. Assume that that odd derivative is not equal to 0. Then that point is called point of inflection. But if f triple dash, which is odd derivative, is 0, then I will calculate f fourth derivative. Suppose if it is less than 0, then again that point a is local maximum. Like that it will move. Like that it will move. Local minimum, same thing. Say I can say you local minima means what? The graph will be like this. This is a left neighborhood, right neighborhood. So first hand derivative I am telling. Can I say f dash a will be 0 and f dash a minus decreasing, no? So negative to f dash a plus positive. So negative to positive through 0. F dash x is changing its sign. Then it is local minimum. Then what will be the second derivative test? F dash a will be 0 and f double dash a will be local minimum, no? So greater than 0. Greater than 0. Then see, I am mixing both nth derivative, now local minima, local maxima, to make you clear nth derivative. Listen carefully, I am repeating the statement. Suppose I got f dash x equal to 0, first derivative, order derivative, 0. Then I will go for next derivative, f double dash. I got positive, local minima. I got negative, local maxima. But if f double dash is 0, I got. Then I will go for f triple dash. If it is not equal to 0, that is called point of inflection. If it is equal to 0, which is odd derivative, then I will go for f fourth derivative. If it is positive, local minima. If it is negative, local maximum. Suppose if f fourth derivative is also 0, then I will go for fifth derivative. Like that it continues. So please remember, odd derivative, even derivative. That is the language of local minima, local maximum, point of inflection. So global maxima and global minima. See, when I said local minima, local maxima, for a function, suppose I have a function like this. See, these are the different places where I have function as having local minima, local maximas. This local minima is more than this local maxima. A local minima more than a local maxima. So in a function in the given interval, in any interval, it can have several local minimas, several local maximas. Among all the local minimas, the minimum is called global minima. Among all local maximas, greater will be is called global maxima. Okay. So I discussed most of the important points regarding this differential calculus. But how many you discuss, the more number of problems you practice, you will get perfection. So I tried with some different problems, but due to its time constraint, I discussed some problems. Try to do more problems to get understand of the concepts. Thank you.